wave nature of light. Today we'll talk about light. Light, it is an external factor that affects eye, causing the sense of vision. As you know, when the light falls in our eyes, we can see any object. So this is the meaning of light. It is an external factor, not internal. It comes from outside. So when light falls on any object, it will cause the vision or the sense of vision. Now we want to know what is the nature of light. Is a light mechanical wave or electromagnetic wave? As you know that, as a light don't need medium to travel through it, so light waves are electromagnetic waves. So now, are light waves are transverse wave or longitudinal wave? The answer is light is transverse wave. Why a light transverse wave? As you know, the particles of light vibrate perpendicular to the direction of wave propagation. This means that the light waves are transverse wave. So, as we know, the nature of light are electromagnetic waves and transverse. Electromagnetic, why? Because they don't need medium to travel through it. And transverse wave because the particles of medium vibrate perpendicular to the direction of wave propagation. If you want to know what is the speed of light, the speed, it means the speed of anything equal a distance over time. So the speed of light, the distance covered by light in 1 second. Again, the speed of light, the distance covered by light in 1 second. So the equation will be this. Velocity equal distance over time. Now we will take a problem about the velocity. Calculate the distance between the Earth and Moon. We want to know the distance between Moon and Earth. If you know that the reflected light on the Moon's surface reaches the Earth after 1.3 seconds, يبقى time here equal 1.3 seconds. And you know that the velocity of light is constant in one medium equal 3 times 10 power 8 meter per second. Magic triangle. Velocity, distance over time. If you want to know distance, so distance will be equal velocity times time. So distance between Earth and Moon equal distance equal velocity by time equal 3 times 10 power 8 time from Moon to Earth, which reached by light 1.3. So will be equal value in meter. Now we want to know all light waves are visible? No. There are light waves which visible characterized by wavelengths range between 380 to 700 nanometer. So we can see light which have wavelengths between 380 nanometer to 700 nanometers. So what is meant by visible light? One of components of electromagnetic wave of a spectrum range between wavelengths 380 to 700 nanometers. The wavelengths of light which less than that, we can't see it. The wavelengths of light which more than that, we can't see it. So visible light that we can see, its wavelengths range between 380 to 700 nanometer. As you know, wavelengths, the unit is meter or centimeter or very small length, which unit is nanometer. So we can see visible light which range from 380 nanometer to 700 nanometer. Now we'll talk about another property of light, analysis of light. Analysis of white light. Can white light split into 7 spectrum colors? Of course, yes. What is meant by analysis of white light? It is splitting of white light into 7 spectrum colors. If we have prism and diffuse white light on prism, it will split into 7 spectrum colors. The first light is red and the last one is violet. Now, as you know, 7 spectrum colors, which are red, orange, yellow, green, blue, indigo, and violet. All these waves or spectrum, they have constant speed, but they are different in wavelengths and frequency. As you know that wavelength is inversely proportional with frequency. This means that as the frequency increase, the wavelength decrease, and vice versa. As the frequency increase, the wavelength decrease, and vice versa. If the frequency decrease, the wavelength will increase. Now we'll talk about the spectrum of 7 spectrum colors. When white light falls on prism, it will split into 7 spectrum colors. The lowest deviation is red, and the highest deviation is violet. This means that the lowest one in deviation, it means the lowest frequency and the highest wavelength. This means that the red is the lowest one in deviation, and this means the lowest frequency and the highest wavelength. What about the violet wavelengths? The violet light. The violet light will be highest deviation. And this means as it is highest deviation, it means highest frequency and lowest wavelengths. Okay, let's talk about another property for light. Light has energy. What is energy of light waves? A light energy is directly proportional to frequency. This means that as the frequency increases, the energy of light waves increase. The highest light has highest frequency, it means highest energy. And the lowest one in frequency, the lowest one in energy. It means as frequency increases, energy of light waves increases and vice versa. Which one has high frequency, the red one or the violet one? You know that the red one has the highest frequency. It means the energy of red light is more than the energy of violet. And this equation is proved by a scientist called Max Planck. Max Planck is a scientist who proved that the photon energy equal constant value times the photon frequency. If we want to know the energy of any light color, right, like red or orange or green, we have to use this equation, the photon energy equal constant times photon frequency. And if I ask you, which one has a greater energy, the photon of red light or the photon of violet light? Of course, the red light. Why? Because the frequency of red light is more than the frequency of violet color, violet light. The frequency of red light is more than the frequency of violet light. As the frequency increases, the energy of light increases, so the red light has more energy than violet light. Thank you.